Hi everyone, welcome back. In this video we'll be looking at what's a cost function and how it helps you in predicting and building your own model. So in order to say in simple possible words, cost function it's the sum of the predicted values minus the actual value, then we sum it up all together for all the data sets we have got, and then we divide it by the number of data sets we have got. We divide it by 2m. So if you look over here, I've written down the cost function. So we are subtracting the actual value from the predicted value, and then we are dividing it up by 2m, not by m. Now you can ask why we are dividing it by 2m. It's just what the formula is. And then what we do is we iterate it over all the data sets we have got, and the cost function is the square of it. So if you say me, what's the difference between your own value, which you have predicted, minus the actual value, and then you square it up, cost function is exactly what we are talking about over here. So if we plot a graph of the cost function over here, in this case, the equation of this graph is y equals to wx plus b. W works as a gradient over here, whereas c is the y-intercept. So we have got cost function, the value of the cost function on the y-axis. Sorry, it's not the y-axis, it's the z-axis over here. The x-axis shows the w, which is the weight of the equation, or can be said as the gradient as well. And then we have got b as a y-intercept. So if we look over here, we can say that the model is gonna be working the best when we have got cost function's value at its lowest. So if we see over here, the height of this equation gives us the cost. So if we see at any possible point where the height is the least, we understand that those values helps us in building the equation which predicts the model in the best possible way. So in this case, it's gonna be 0, 5. So it's the values which helps us in building up the equation, which helps us in predicting and building up the model.